So the next concept to the VLANs will discuss the concept of trunking. Now here in this section, concept of trunking, we are going to deal with the same concept of VLANs. But what if I have some VLANs users of VLAN 10 connecting on switch 1 and some other VLANs of 10 connecting on the other switch? We are going to see how exactly the traffic is flowed between the same VLAN users on different switches. So that's where your concept of trunking comes into picture. Now before we actually discuss about the complete trunking concepts, first we'll try to understand why there is a need for trunking or what exactly we're required to do here. But first thing we'll see, a single VLAN can span over multiple switches. Now single VLAN can span over multiple switches means there is a possibility that in your production network you have some users of IT department maybe sitting on the ground floor, maybe on the first floor here, and there are some users of IT department, maybe some users on the second floor, and there is a possibility that there are some users of the IT department on the third floor. Now connecting everyone to the same switch physically it's not possible, right? So let me show you a little bit in a diagram way. Let's take an example. This is my building and I have some multiple floors in that, and there are some users of IT department, some devices, there are some users sitting in the ground floor, or they are doing the work in the ground floor, and there are some users on the next floor, and there are some users on this floor, and there are some users on this floor. Now as they are geographically somewhat far from each other, connecting them to the same switch is not possible. But if you want to do that, then in that case I need to bring some cabling here, and then cabling from the top floor, and then cabling from here, and then some extra cabling required from this side. So which means physically connecting everyone to the same switch, it's going to require some extra cabling. So instead what we do is we go with a solution where we connect these users to the nearest possible switch, and then these users connect to the nearest possible switch in the same floor, and then all the users of this will be connecting to the nearest possible switch generally, and then the users on the ground floor will be connecting to the nearest possible switch here. And then we can extend the LAN by connecting a cross cable between switch to switch. Now this is something what you will find in the production networks, and this is the way we connect, because it's not really possible for everyone to connect on the same switch. If they're in the same building, that may be possible, but if you just assume that there's one more building and there are some users of IT present here, and connecting everyone to the same switch is not possible. So this is something what we do, and this is something we should not do it. So now what I mean to say here is a single VLAN can span over multiple switches means there is a possibility that the users of the same VLAN means same department, might be on different switches. They might be on different switches, like some users of IT connecting on this particular switch here, some users of IT connecting on this switch. Now we want to understand how the communication process happens in these scenarios. We are saying that same VLAN, same broadcast domain, and they can communicate with each other, but if they are on different switches, how the communication process happens. Now in order to forward the traffic of the same VLAN user from one VLAN to another VLAN, there is one solution we can use. We can pass the traffic using a separate links for each and every VLAN. That is one possible solution we can think about, where you can have some VLAN 1 user. If you want to send the traffic from VLAN 1, as they are on different switches, we can have a separate link for VLAN 1, one separate link for VLAN 1, and one separate link for VLAN 2, and then one separate link for VLAN 3. You can see there is a separate link for VLAN 3. So which means between switch to switch, we can have one separate VLAN for each and every user, each and every VLAN, but this is not a scalable solution. Because let's take an example, I got 20 VLANs. Will you go with 20 links between the switches? This is something not possible, so we don't use this scenario. So passing the VLAN traffic using separate links for each and every VLAN is something not scalable, not really applicable in the production networks. Instead, what we do? Now what we can do is we can use only one common link which can carry all the VLAN traffic, which means we can ensure that the VLAN 1 traffic, VLAN 2 traffic, VLAN 3 traffic, they all can go on the same link without interfering with each other. That is possible. So that's what we are going to see, how it is possible, how it is going to allow the multiple VLAN traffic on the same link without interfering with each other, without conflicting each other. So to understand that process, so before we get into the actual process, that is what frame tagging, let's try to understand there are two different types of links we have here. The first link, we have something called access links. Access link are the links which are connecting to the end devices. These are all access links. So they belong to just one VLAN. By default they belong to VLAN 1, but we can shift them into VLAN 10 or VLAN 20 or VLAN 30 as per your requirement. But at the end, the ports which are connecting to the end devices, we call them as access links, and they just belong to only one VLAN. But the link which is connecting between switch to switch, and this particular link, it doesn't belong to any VLAN. So which means it's not a member of any VLAN, but it's going to carry multiple VLAN traffic. So multiple VLAN traffic means here, if you just take an example here, I got 3 different VLANs. You can see the names here. I have given some names as red here. So if any one user of the VLAN red want to communicate with the user of the VLAN red on a different switch, he should go from the same link, and that link we call it as trunk link, which means it is carrying the VLAN red traffic, and also it is carrying the VLAN blue traffic. You can see the user of the VLAN blue want to communicate with the blue VLAN user on a different switch. He should be going on the same link. And also there is one more VLAN, green VLAN. You can see here, if the green VLAN user want to talk to green VLAN user, he will be going on the same link. So just like here, even though they are going on the same link, still I'm going to differentiate, right? So even though they are going on the same link, but now the question is how the switch is going to differentiate each and every VLAN. Okay, so the trunk link is the link which carries multiple VLAN traffic, but now the question is how it is going to identify. Like here I'm using different colors for identification, but in case of switches there is a method called frame tagging happens. Now this frame tagging is a method which will ensure that even though they are going on the same link, still they will be differentiated without interfering with each other, without having any issues. So let's see what is this frame tagging happens. So in order to make sure that the same VLAN users on 2 different switches to talk to each other, like here you can see the blue VLAN 1 should communicate with VLAN 1 on a different switch. They will be going on the same link, but there is a color differentiation here. The VLAN 2 communicating with VLAN 2 on a different switch, they will be going on the same link here. And the VLAN 3, that is the green VLAN, communicating with the green VLAN on a different switch, they are going on the same link. Now what exactly switches will do is, when the particular frame is sent, like in this scenario, the second example, VLAN 1 is sending a frame. Before it sends on the trunk link, before it sends, it is going to add the frame with some tag information. So we call this as frame tagging process. Now this tag is actually containing something called VLAN ID. Now in that particular tag, it is going to add the VLAN number and it is going to send over the trunk link. Now here, for easy understanding, we got different colors, but the frame is sent with a tag, and in that tag is like extra header information added inside your frame or a packet. Now why it is doing that? Because the switch 1 knows exactly from where it is coming. It's coming from VLAN 1, but the switch 2 do not know exactly which VLAN it belongs, because all looks same, they all are frames. Now there should be some differentiation to inform the remote side of the switch, that is switch 2. Now it will be sent with a tag. Now the switch 2 will receive the frame with a tag, and it will see the tag information. It realizes that it belongs to VLAN 1. okay, and it will remove the tag and it's going to send back to the switch 1 as a normal frame. So if you just try to observe here, when the switch is sending, it is sending as a normal frame. Sorry, when the PC is sending, and when the switch is receiving, it is as a normal frame, and when it is sending on this side, it is just as a normal frame. So it is just a frame to frame, but when the particular switch is sending on the trunk link, it is going to add the tag here, which means when it is sending, it is going to add the tag on that particular frame, and once it receives on the other side, it is going to see the tag and it is going to remove that particular tag, because once it sees the tag, it comes to know that this frame belongs to VLAN 1. So the switch 2 will ensure that it is going to send only to the VLAN 1 and it will not send to any other VLANs. Now this frame tagging is a method which is going to ensure that even though there are multiple VLAN traffic going on the same link, but still each and every frame is differentiated and identified on the remote switches, and this will ensure that even though they are going on the same link, still the VLAN traffic is differentiated. They become a part of the separate broadcast domain. Now this is what frame tagging methods, and this frame tagging method happens only on the trunk links, and when it is sending anything, it is going to add the tag. Once it receives anything, it will simply remove the tag after seeing that particular VLAN information in that. Now frame tagging is mandatory and it is a default process which happens on the trunk links.